In today's class, we have a little challenge again. But before we go into today's challenge, my name is Jakes Anemo. And if you are new to this channel, kindly subscribe and turn on the bell notification button so that YouTube can notify you whenever we drop wonderful video like the one you are about to watch now. All right, let's go to what we have for today. We will have solution. All right. So we write out our question, which is 6m square u square minus 4m u cube all over 9m cube u minus 4m u to the power of 3. Now, from the numerator, we look out for the terms that are common to this part and this part. So we discover that 2 can go into 6 without remainder, 2 can equally go into 4 without remainder. Here we have m, then here we also have m. Here we have u, here we have u. So we factorize the terms that are common here. So from here, this will now give us 2. We are having m squared here, but here we are having just one single m. So we bring out just one single m. Then we are having u squared, we are having u cubed. So u squared can come out of here. So here will now give us u squared, bracket. So we now use these terms we have here now to strike out this, to divide this. So we now have this to be 6m squared u squared all over 2mu squared. This automatically will give us 3. We are still left with 1m. M, then minus. If we use this to divide this will give us 2. M, we cancel out m. Then u squared will cancel out u squared here. We'll still be left with just 1u. Close bracket. All over. We do same here. So here, in terms of numeral, no number is common. So no number is common. So we go to the alphabet. M is here, M is here, U is here, U is here. So we bring out M and U. Of course, 9 will remain here. Then M, we only brought out one M from here. So we are still left with M raised to power 2. U, we cancel out U. Then minus 4. M is already out, so M will leave the system here. U, we take one U from here to give us here U, now give us U to the power of 2. Close bracket. All right. Now, at this point, what you should be thinking of is we are having 9 here, we are having 4 here, we are having M squared here, we are also having U squared. So we can reduce this one to 3 raised to power 2 because 3 raised to power 2 will give us 9. And this one, 2 raised to power 2, which is 4. So when we do that, we proceed by rearranging this up, which is the numerator, will remain the same. So this will give us 2mu squared, bracket open, 3m minus 2u, close bracket, all over. This will remain mu bracket. So we take this to 3 to power 2, m to power 2, minus 2 to power 2, then u to power 2, close bracket. All right. Now that we have this, just take a look at this again. Here is square. All the terms here now, they are all carrying square. So we can bring out these terms to give us 2mu squared, bracket 3m minus 2u, close bracket, all over mu bracket 3m minus 2 u all squared. All squared. Now, what do? We make use of what is called difference of two square. And the difference of two squares says that you have a minus b all squared is equal to bracket open a plus b bracket a minus b close bracket. So this expression is same thing as this. So we can bring this form out of here. All right. So this now give us 2mu squared bracket 3m minus 2u all over mu bracket 3m plus 2u close bracket 3m minus 2u close bracket. Okay, so this we have here is same thing as this expression we have here now. So from here, we discover that we're having 3m minus 2u and 3m minus 2u. So both of them can leave the system, can strike themselves. Here we are having m here, we are having m here. We are having u squared, so one u can strike out this, we are having u here too. So if we look at what we are left with, because one u will play out here, so I'm still going to have one u out here. So this will now give us, this now implies 2u all over here, nothing is here again. We're only having 3m plus 2. So we now have 3m plus 2u. Right. So this is our answer. Our answer QED. Okay, so